Assalamualaikum warahmatullahi wabarakatuh and a very good morning to my distinguished audience. Today, I will give a speech titled From Newton to Now, Discovering the Secrets of Gravity. But first and foremost, let us give thanks to God Almighty for allowing us to be here with good health and without any shortages. Theoretical physicist Albert Einstein once said, gravitation cannot be held responsible for people falling in love. While love is indeed a complex force, today I will focus on the different kind of attraction called gravity. We have heard about gravity since our early childhood, but you must be wondering what is gravity actually. Ladies and gentlemen, gravity is a force that exists between any two bodies that have mass. It is what keeps our feet firmly planted on the ground, makes us able to walk and run on this planet steadily. It is also this force that controls the motion of other planets around the sun, including our beloved planet Earth. But gravity is more than just a force that pulls objects down. It is a fundamental interaction that shapes the structure of the universe. Gravity governs the motion of galaxies, hold the solar system together, and even influence the path of light. Now, I will narrate a well-known story of Newton's contribution to gravity. The idea of gravity came from Sir Isaac Newton, a great scientist of his time in the 17th century. According to tales, while sitting under an apple tree, Sir Isaac Newton was pondering the wonder of the universe. Suddenly, an apple dropped on his head, and he discovered that it is what the same force that made apples fall from trees and make their way back to earth, as well as causing them to descend towards the sun. This anecdote, though likely exaggerated, symbolized Newton's moment of realization about the universality of gravity. Following Newton's law of universal gravitation, every mass attracts every other mass by a force called weight. This force is directly proportional to the product of their masses, but inversely proportional to the square of the distance that separates them. Or in simpler language, the gravitational pull between two objects becomes stronger when they are closer or their size increases. For example, racing cars. The making of the racing cars use this principle by reducing their weight, making them to move faster. This simple yet profound law explains that not only the fall of apple, but also the orbits on planets and moons. Newton's work laid on the foundation of classical mechanics, providing a framework that describes the motion of objects both on Earth and in heavens. Indeed, his laws of motion and universal gravitation were pivotal in advancing our understanding of the physical world. They allowed us to predict what motion of celestial bodies and even launch the age of exploration as sailors and scientists use the Newton's law mechanics to navigate the seas and chart the stars. Ladies and gentlemen, gravity is everywhere. We can even feel and see the gravitation principles in our everyday life. If you want to have an idea of gravity in everyday life, let us consider a simple example, which is dropping a ball. When you let go of a ball, it will fall to the ground. Obviously, this occurs because the Earth's mass leads a gravitational pull that attracts the ball towards its center. It is this same force that results in our feeling of weight. Without gravity, we would float endlessly, unable to perform even simple tasks like walking, sitting, or even holding an object. Gravity does not only affect things on Earth, it goes far beyond that. It is why the moon revolves around the Earth and why the Earth orbits around the sun. In space, gravity controls the movement of celestial bodies, causing planets to move along elliptical paths and keeping moons close to their planet. This concept was mentioned in Quran in Surah Yasin from verse 36 to 40. A'udzubillahi minasyaitonir rajim. La syamsu yanbaghi laha an tudrikal qamara wa la yusabiqun nahar wa kullun fi falakin yasbahun. It means it is not permitted for the sun to catch up with the moon, nor the night outstrip the day. Each just swims along its own orbit. Indeed, this verse beautifully describes the orderly movement of celestial bodies guided by the invisible hand of gravity. Furthermore, gravity's influence is seen in various phenomena we encounter every day. For instance, the tides of our oceans are a result of the gravitational pull of the moon. As the moon orbits the Earth, it exerts a gravitational force on the planet's water, causing it to bulge outwards, leading to high and low tides. This interaction between the Earth and the moon highlights the interconnectedness of celestial bodies and their gravitational influence. Now, moving on. If we were to talk about gravity, we couldn't run from this theory, which is Einstein's theory of general relativity. As time went on, Albert Einstein further expanded our understanding of gravity with his theory of general relativity in the early 20th century. According to his theory, he proposed that gravity is not just a force, but a curvature of spacetime caused by mass. Furthermore, he said that massive objects like the sun create a dimple in the fabric of spacetime, and other objects move along the curves in the dimple, which we perceive as the gravitational pull. Einstein's theory of general relativity revolutionized our understanding of gravity. It replaced the Newtonian concept of gravity as a force with the idea that massive objects warp the fabric of space-time, creating a curvature that dictates the motion of objects. This concept was elegantly confirmed by observations of light bending around massive objects, a phenomenon known as gravitational lensing. Einstein's theory has profound implications influencing modern astrophysics and cosmology. Indeed, by using this theory, we develop useful tools that are used all around the world, such as Global Positioning System, or known as GPS. The use of satellites accounts for time dilatation effects due to their high speeds relative to the Earth's surface. Without these corrections, GPS accuracy would degrade rapidly. This practical application of general relativity shows how theoretical physics can have direct benefits in our daily lives. After listening to those things, you might get confused about gravity, right? Perhaps it seems to be more complicated than what it is. Never mind, let us illustrate gravity with an analogy. This would make you have a better understanding of gravity. To illustrate in everyday terms, think of a spacetime as a stretched rubber sheet. If you place a heavy ball in its center, it creates a depression. If you then roll a smaller ball near the depression, it will spiral inwards toward the heavy ball. This analogy helps us to visualize how massive objects like stars and planets work space-time and cause gravitational attraction. This concept simply explains how the gravitational force actually works. Indeed, gravity is very important in the creation of planets, stars, and galaxies as well. Gas and dust in space cling together and starts glowing, finally developing into stars that glitter amongst our grief-stricken dark night. This in turn affects the formation of planetary systems around these stars. My distinguished audience, indeed, God creates this force because it has its own role in the universe. Gravity is a fundamental force that not only keeps us grounded but also orchestrates the grand balance of celestial bodies in the universe. It is a force that acts at all scales, from the smallest to the largest. Gravity drives the formation of stars and galaxies, govern the motion of planets, and influence the evolution of the universe. By finding out about the concept of the theory of gravity, it should make us think about the power of our God Almighty Allah Subhanahu wa Taala and makes us closer to Him as we realize how powerless we are without Him. Our understanding of gravity has profound implications for our comprehension of the cosmos. Gravity is the force that causes galaxies to cluster together, forming the vast cosmic web. It also covers the dynamic of black holes, the enigmatic regions where gravity is strong that not even light can escape. Black holes, validated by general relativity, provide a window into extreme effects of gravity and space-time curvature. Now, in our era, in the contemporary era, modern science and technology rely on our understanding of gravity. For instance, engineers and architects must consider gravitational force when designing buildings and bridges. Even astronomers use gravity to understand the movement of stars and galaxies. Without the knowledge of gravity, many aspects of our modern life, such as space exploration and satellite communication, would not be possible. Moreover, gravity plays a crucial role in our efforts to explore the universe. Space agencies, a well-known one such as NASA and ESA, use gravitational assist to propel spacecraft to distant planets. By flying close to the planet and using its gravitational pull, a spacecraft can gain speed and change its trajectory, enabling missions to explore the outer reaches out of our solar system. Furthermore, there is a phenomenon called gravitational waves. Indeed, another exciting development is our understanding of gravity came in the form of gravitational waves. Predicted by Albert Einstein in 1916 and is first steadily observed in 2015, these ripples of spacetime are caused by some of the most violent and energetic processes in the universe, like colliding black holes. The discovery of gravitational waves opened a new window for observing the universe, allowing scientists to study events that were previously undetectable. Gravitational waves provide a new way of observing the galaxy, complementing traditional electromagnetic observations. They carry information about cataclysmic events such as neutron star mergers and supernova. This allows us to probe the most extreme environments in the universe. The detection of these waves requires incredibly sensitive instruments like the Laser Interferometer Gravitational Wave Observatory, aka LIGO, which can measure distortions of spacetime as small as fraction of the diameter of a proton. My distinguished audience, I would like to ask, have you ever heard of black holes? Well, speaking of black holes, these are regions of spacetimes where gravity is so strong that nothing, not even light, can escape from them. Black holes are formed when massive stars collapse under their own gravity at the end of their life cycles. The study of black holes has provided deeper insights into the nature of gravity and the behavior of matter under extreme conditions. Black holes challenge our understanding of physics, especially at the interactions of general relativity and quantum mechanics. The event horizon, the boundary beyond which nothing can escape, marks a point where our current theories break down. Studying black holes and their interactions with surrounding matter offers clues about the fundamental nature of spacetime and ultimate fate of the matter falling into these cosmic giants. Ladies and gentlemen, now we have reached a modern era where we are able to further our study of gravity. As we look to the future, research into gravity continues to be a vibrant field. Scientists are now working on identifying general relativity with quantum mechanics, the theory that describes the physics of very small. This effort, often called a search for a theory of everything. Theory of everything aims to provide a more comprehensive understanding of the fundamental force of nature. Indeed, one promising area of research is quantum gravity. What I mean by saying this is, it seeks to explain how gravity works at the smallest scales. This could lead to a new discoveries about the origins of the universe and the fundamental of nature of reality. Additionally, studying gravitational waves and black holes can reveal more about the formation and revolution of galaxies and the fate of the universe. The pursuit of unified theory has led to the development of various models, such as string theory and loop quantum gravity. These theories attempt to reconcile the apparent contradictions between general relativity and quantum mechanics, offering potential insights into the nature of space-time, the behavior of particle at the Planck scale, and early moments of the universe. Now, I still remember back in Form 5 in physics, I have learned about the dark matter and dark energy. Gravity also plays a crucial role in our understanding of dark matter and dark energy. These two mysterious components that make up of the universe. Dark matter. Dark matter is thought to be an invisible substance that exerts gravitational force holding galaxies together. On the other hand, dark energy is believed to be responsible for the accelerated expansions of the universe. Henceforth, by studying how gravity interacts with dark matters and dark energy, scientists hope to uncover the true nature of the enigmatic phenomenon. This research could lead to the groundbreaking discoveries that reshape our understanding of the cosmos. The observations of galactic rotation curves, gravitational lensing, and the cosmic microwave background provide indirect evidence of dark matter and dark energy, highlighting the critical role gravity plays in these investigations. Ladies and gentlemen, gravity now has its evolution of the universe. Gravity has been a driving force in the evolution of the universe since its inception. After the Big Bang, gravity caused matter to coalesce into stars, galaxies, and clusters of galaxies. Over these years, gravity has shaped a large-scale structure of the universe, creating the vast cosmic web of interconnected galaxies as we can observe today. The understanding of gravity's role in the evolution of the universe helps us piece together the history of the cosmos and predict its future. This knowledge allows us to appreciate the complexity and beauty of the universe and our place within it. By studying the cosmic microwave background radiation, astronomers gain insights into the conditions of the early universe and the influence of gravity of the formation of cosmic structures. Now, let us move to the discussion of the gravity in space exploration. This is very interesting topic to be discussed. Ladies and gentlemen, indeed, gravity is a fundamental consideration in space exploration. When launching rockets, scientists must calculate the gravitational pull of the Earth and other celestial bodies to ensure that the spacecraft can reach its intended destination. Gravity assist or slingshot maneuvers are used to boost the speed of spacecraft by using gravitational pull of the planet. Moreover, gravity influences the design and operation of space missions. Space agencies must account for microgravity environments when developing equipment and conducting experiments in space. To understand this gravity is essential for planning missions to the Moon, Mars, and beyond. For instance, the International Space Station, or ISS, serves a laboratory for studying the effects of microgravity on biological and physical systems. Astronauts conduct experiments that provide a valuable data on how living organisms and materials behave in the absence of significant gravitational forces, contributing to the advancements in medicine, material science, and in other fields. In the medicine field, gravity is related to humans' well-being too. Gravity also affects human health, especially for astronauts who spend extended periods in space. What I mean by saying this is, in microgravity, for instance, the human body undergoes various changes including muscle atrophy, bone density loss, and fluid redistribution. Scientists study these effects to develop countermeasures and ensure the health and safety for the astronauts. On the other hand, on Earth, gravity impacts our daily lives and well-being too. What I mean by saying this is, it influences how posture, circulation, and even our sense of balance. Understanding gravity's effects on the human body can lead to improvements in medical treatments and technologies. For example, research into osteoporosis and muscle wasting conditions benefits from studies conducted in microgravity, providing insights into the mechanisms of bone and muscle loss. Ladies and gentlemen, ultimately, gravity is also related to the cultural significance. Gravity has also influenced human culture and creativity. It has inspired countless works of art, such as literature and music. This concept of gravity appears in myths, legends, and religious texts, symbolizing both physical and metaphysical forces. While, on the other hand, gravity often represents themes of grounding, stability, and the inevitability of change. For instance, artists use gravity as a metaphor for the human condition, exploring themes of attraction, loss, and the passage of time. For instance, the story of Icarus in Greek mythology, who flew too close to the sun and fell due to the pull of gravity. This story serves a cautionary tale that abyss than the limits of the human ambition. Now, we will delve into the educational importance of gravity. Teaching and learning about gravity is fundamental to science education. Understanding gravity helps students to grasp essential concepts in physics, astronomy, and engineering. It fosters critical thinking and problem-solving skills by preparing the next generation of scientists, engineers, and innovators. Educational programs and outreach initiatives aim to inspire curiosity and enthusiasm for gravity and other scientific topics. What I mean by saying this is, by engaging students in hands-on experiment and interactive learning experiences, educators can cultivate a long life passion for science. Demonstrations of gravity, such as dropping objects of different masses, show that they fell at the same rate. This helps students to understand the universality of gravitational acceleration. Actually, gravity also helps in technology innovations. Advance in our understanding of gravity, it has led us to numerous technological innovations. For example, the principle of gravity are applied in the design of various transportation systems, from cars to airplanes to high-speed trains. Engineers use knowledge of gravitational force to optimize performance, safety, and efficiency in those mentioned causes. In the field of medicine, gravitational research has contributed to the development of medical imaging technologies, such as MRI and CT scans. These technologies rely on our understanding of physical forces to provide detailed images of the human body, aiding in the analysis of the treatment. The design of artificial hearts, prosthetic limbs, and other medical devices also benefits from principles derived from gravitational studies. After all discussion, I will now explaining the role of gravity in environmental science. My distinguished audience, gravity also plays a crucial role in environmental science and conservation. It influences the movement of waters in rivers, lakes, and oceans, affecting weather patterns and also our climate. Understanding the gravitational forces help us to predict natural disasters like floods and tsunamis, enabling better preparations and response. Moreover, gravity affects the distribution of resources on Earth, such as minerals and fossil fuels. Knowledge of gravitational forces assists in the exploration and sustainable management of these resources. It is ensuring their availability for future generations. For instance, the study of gravitational anomalies helps geologists locate oil reserves and mineral deposits, contributing to more efficient resource extraction. Ladies and gentlemen, I do believe that most of us love arts, right? Gravity can also be related to arts. Indeed, gravity influence extends beyond science and it can also be seen into the arts. Artists and performers often explore the concept of gravity in their work, using it as a tool for expression and creativity. For instance, dancers play with gravity through movement, creating a graceful and dynamic performances that captivate the audience. In visual arts, gravity can be seen in sculptures, in installations, and kinetic art. Artists use gravity to create balance, tension, and movement, challenging viewers' perceptions and inviting them to contemplate the force that shape our world. The interplay of gravity and aesthetics is evident in works such as Alexander Cradle Mobiles, and where a suspended element move gracefully under the influence of gravitational force. Now, gravity also plays role in shaping the history. Gravity has also played role in shaping human history. What I mean by saying this is the development of technologies that harness the gravitational forces such as sculptures, ambush, and latest firearms significantly impacted warfare and defense strategy. These advancements altered the course of battles and influenced the rise and the fall of civilization. For instance, we can observe this in the World War I and World War II. The understanding of gravity also influenced navigation and exploration. Early Marines relied on gravitational forces to navigate the seas using the stars and Earth's magnetic field to guide their journeys. Indeed, this knowledge enabled the discovery of new lands and the expansions of trade and in cultural exchange. While on the other hand, in the realm of sports, indeed gravity is a key factor in sports and recreation. Athletes must understand and leverage gravitational force to excel in their respective disciplines. In sports like basketball, gymnastics, and diving, mastering the effects of gravity is essential for achieving peak performance. Recreational activities like skiing, surfing, and skateboarding also rely on principles of gravity, even though they are not the competitive one. Participants must balance and maneuver their bodies in response to gravitational force, enhancing their skills and enjoyment of these activities. Indeed, understanding how to work with gravity allows these athletes to maximize their performance, and whatever it is, a high jump or clearing the bar, or a gymnast executing a complex routine. Ladies and gentlemen, in conclusion, gravity is a fundamental force that not only keeps us grounded but also orchestrates the grand balance of the celestial bodies in the universe. From apples that fall from trees to complete orbits of planets and stars, gravity plays a crucial role in shaping the universe. Ultimately, our understanding of gravity has come a long way from Newton's apple to Einstein's spacetime, and it continues to evolve with new discoveries. By learning about gravity, we gain deeper appreciation for the natural world and the universe. This reminds us of the power and precision which our world is designed. As we continue to explore and understand this mysterious force, let us also remember to stay humble and be grateful for the wisdom and creativity of our Creator. It's Allah Subhanahu wa Ta'ala. That's all for me. Thank you for listening and paying attention. Thank you.